NMR is the most common form of spectroscopy that we'll be doing all semester, so I'm going to show you how to prepare a couple different types of samples. Bottom line is start with a clean and dry NMR tube. I've got 2 to go, ready to go. I'm going to prepare a liquid sample, and in addition to that, I'm going to prepare it as what we call a neat sample, which means the only thing I'm going to put in this NMR tube is this liquid followed by a reference compound. So let's go ahead and start with a neat sample. This is limonene once again. I'm going to take a clean pipette. All I need to do in terms of a liquid neat sample is to add enough of this oil to the NMR tube such that I want a total height of about 4 centimeters. I need a little bit more. That looks good. Okay, I'm going to cap up the limonene so I'm not breathing this the whole time. Now, this is just our sample at this point. This is the way we're going to want to prepare liquids whenever we can, especially given that we have plenty of liquid to work with. So we just put it all in there 4 centimeters high. If we don't have enough liquid to put in there to get it 4 centimeters high, we can use a solvent. We've got the common solvents available to us. Most of the time we're using chloroform, deuterated chloroform, so that the hydrogens don't show up in our HNMR spectrum. So deuterated chloroform is what we typically use for dilutions. Sometimes we're forced to use dimethyl sulfoxide, which is another common one, and even sometimes we have to use methanol. We always try this one first though. This is the cheapest solvent available to us. This one's a little more expensive, this one's really expensive. So chloroform, that's the widely available one. We're not going to need to use it though in this case because we've got plenty of liquid inside this tube. The only thing we need to add to this though is the reference compound. So tetramethylsilane, TMS for short, is something we've probably been talking about in a lecture recently, and this needs to get added to this liquid sample, this neat sample. Now with this one you got to be moving quickly because it comes out of the pipette really quickly, and our goal is to get about 5 to 10 drops of this tetramethylsilane into this tube. And so what I'm going to do is I'm just going to hold this as close as I can and just count out 5 drops. Wow, that was pretty tough. It was coming out quickly like I predicted. The other thing about tetramethylsilane is that I'm going to want to cap this up as soon as I can because it's extremely volatile. Not only cap this up, I'm going to replace this here, but also get an NMR cap onto this as soon as possible as well. Hopefully your cap is clean, that's also essential. Looks like the TMS did not mix in right away, so all you have to do is invert this a couple of times. Now it looks like it did mix in now. And this NMR sample is ready to go. The advantage of a neat sample again is that we can do the full set of tests. We can do hydrogen NMR, we can do carbon NMR, we can do depth experiments. That's ready to go. Maybe the one last step is to wipe off the outside, get rid of all the fingerprint. Now the second sample I'm going to prepare is a solid sample, so here's our compound. And what I always suggest is to grab one of these little plastic vials that are available in the center bench bottom drawer and take a spatula, and you're just going to fill in this plastic vial about 1/3's worth. So in other words, the total volume of this plastic vial about 1/3 full of your solid organic compound. And let me see if I can just scoop out a good sized wad here. Okay, normally you'd put more in there for the interest of time. I'm just going to put 1 scoop in there. That's probably going to be enough anyways to work with. Get the cap back on. All right, so this is a solid, so we can't just add TMS to this and add it to the tube. We're going to have to add a solvent. We have no choice but to add chloroform in this case. So chloroform is the one we typically choose. I've got another clean pasture pipette. And notice that I'm doing this in the fume hood too. You do not want to be breathing chloroform. It's a suspected carcinogen. You don't want to have this spill on you, nor do you want to be breathing this. Now this is deuterated chloroform such that it's not going to show up in our spectrum. That's why we use this. So anything we use has got to be deuterated. Now I'm trying to aim for a total volume in this vial of 0.7 milliliters. There's graduations on the vial that I can see what I'm doing. Okay, that looks pretty good. Cap goes back on. This is also a fairly volatile solvent. All right, so that goes down. Cap on tight. Now what I want to make sure is that the solid completely dissolves before I transfer to the tube. Looks like it went into solution right away, and all I have to do is transfer to the tube. So assuming that you put 0.7 milliliters of total volume in there, that's going to give us the proper 4 centimeters of height. Okay, one last thing. In the event that your solid does not completely dissolve into this solvent, one thing you can rig up is a little filtration system where you stick a little piece of cotton somewhere in this clean pasture pipette. You take what you can out of the vial and you pass it through this cotton into an NMR tube, and that way the cotton is going to pick up any of the solid that did not dissolve, and it goes into the bottom of your NMR tube. You just add to that with deuterochloroform to get that height of 4 centimeters that we're looking for. So that's if the solid does not completely dissolve in the chloroform, you can do a quick filtration with a pasture pipette. But otherwise, that's how we prepare a solid sample. I'm just going to cap this up, and that is it. Just going to wipe the outside one last time before I transfer this into the instrument room. In this video clip, I'm going to show you how to load a NMR sample in the NMR instrument. First rule of the NMR is to not lean on it in any way. I know it's tempting sometimes to lean on this, but don't do it. It puts the NMR instrument out of alignment. The hatch is normally closed, especially if you're the first person. Always there's a sample spinning in here. It's probably water if you're the first person of the day. This is the sample chamber. So down deep inside the sample chamber, there's a sample. And the way to retrieve it is to rotate this dial 180 degrees. Doesn't matter which direction you go, clockwise or counterclockwise, but always 180 degree motions. So I'm going to go counterclockwise. Don't have your face too close to this. As you can see, you're going to get poked in the eye. You can grab the sample from the top part of it with your fingers, that's okay, but try not to touch anything from the top part of this white spinner. That's what we call this little plastic piece, is the spinner, downwards to the end of the tube. You don't want any fingerprint grease on this setup. So in fact, the way to get this spinner off and get it onto your sample is to use a chem wipe to pull it off. And you're going to lay this water sample down on this foam. My sample is here. I'm going to just put this in a little ways into the spinner. There's a hole in the front part of the NMR instrument that you're going to put the bottom of the NMR tube into and push it down until it bottoms out. And that sets the height of the spinner to the proper height. You need to do this. This is a critical step. You have to do this, because if you don't do this, you're going to put it back in there. It's going to fall to the bottom too far. It's going to break. That's really a bad thing, because the NMR is out of commission for a couple of months at that point. You have to set this height properly by putting it in here. I'm also going to just do a little wipe at the end of the tube, just to make doubly sure that there's no fingerprint grease on this, and just double check it again. Listen for that rushing air sound. That's got to be on. Here's what you don't want to hear is silence, okay? You got to hear air rushing through here, because by the time you put this sample back on here, it's just going to hover indefinitely on top of that sample chamber until I once again rotate this dial 180 degrees. At that point, the sample falls to the bottom. Now, once in a while, the sample won't fall all the way to the bottom. It gets stuck about midway. All you have to do is jigger this dial a little bit, and the sample now falls to the bottom. And I know the video doesn't do it justice, but that sample is spinning very rapidly down on the bottom, and that's a good thing. Also, I've placed a mark on top of the cap just to make sure that I can see the spinning, the high rate of speed spinning for that sample, but it looks good. I can see that it's spinning, and that's loaded. You can close the hatch at this point if you want to keep the dust out, but otherwise that's how you load a sample. Now, to get your sample back out of there, obviously you just repeat those instructions again. So we just analyzed our NMR samples on the machine. We're ready to clean out the NMR tubes. We've got this nice little device for cleaning NMR tubes. It works great. And the first thing I'm going to do is turn on the vacuum. And all you have to do is take the cap off and just slide it onto one of these little plastic outlets. And there's a vacuum that's passing through the entire setup. And so that'll suck our sample out, but you're just going to simply squirt acetone. What I like to do is squirt the acetone on the outside of the tube, and that's sucked through the whole system, and it's cleaning our NMR tube in the inside, if you can just see that. So do this about 3 times. That's usually more than enough to clean an NMR tube. I'm going to run this up and down just to try to dry this as much as I can. I would personally not use an NMR tube that you just clean, because a lot of the time we just simply can't get all the acetone out of this and dry enough for the next analysis. So let this sit for at least a week, or maybe put it in the drying oven if that's available, but otherwise that should be clean. Now if you still see some residue of any kind inside the NMR tube, that means that acetone is not the right solvent to clean this, so you can use water instead. So if acetone doesn't work, try water, but otherwise get your tube clean and dry. So I'm going to do the same thing for this second sample, although I'm going to pick up the pace a little bit so we can get on to other cleaning issues. Okay, once again, I'm just going to squirt on the outside. Okay, the caps. Don't forget to clean the caps too. Remember, we probably inverted the NMR tubes and sample definitely got in the little cap, so I'm just going to do this the good old-fashioned way and squirt inside there, dump it out in the organic waste. Please turn off the vacuum on the system when you're done. Otherwise, we're going to just be continuously sucking acetone vapors into the house vacuum, so get that turned off, and that's it. That's cleaning an NMR tube. Again, I'm going to remind you, probably it's wise not to reuse the tubes until they're super dry, but that's how you do it.